The topic is metals. We have different classifications of metals, materials and metals. So engineering materials can be classified into basic categories. Number one is metals, the ceramics, polymers, composites. So these are the different classification of engineering materials. The chemistries are different, their mechanical and physical properties are dissimilar. So metals are used in manufacturing are usually alloys, which are composed of two or more elements, with at least one being metallic element. Metals can be divided into two basic categories, the ferrous and non-ferrous. The ferrous metals are based on iron. The group includes steel and cast iron. Pure iron has limited commercial use, but when alloyed with carbon, iron has more usage and greater commercial value than any other metal. Non-ferrous, they include the other metallic elements and their alloys. They include metals and alloys of aluminum, copper, gold, silver, and other metals. Ceramics is defined as a compound containing metallic or semi-metallic and non-metallic elements. Typical non-metallic elements are oxygen, carbon, and nitrogen. Ceramics include variety of traditional and modern material. Traditional ceramics includes clay, silica, aluminum, and silicon carbide. Newer ceramic include carbides and nitrides. So these are samples of the ceramics. No? They are used in pipes. They are used in washers. They are used in fillers. Polymers. Polymers usually consist of carbon plus one or more other elements such as hydrogen, nitrogen, oxygen, and chlorine. Polymers are divided into three categories. We have the thermoplastic polymer, elastomers, and the thermosetting plastics. Thermoplastic polymers or thermosoftening plastic is a plastic polymer material that becomes pliable or moldable at a certain elevated temperature and solidifies upon cooling. Samples of thermoplastics are the nylon or the polyamide, mechanical and automotive parts, including packaging, cupboard, hinges, heat-resistant composite manufacture. We have the polyethylene, which are used for mineral water bottles, milk bottles, movable machine parts, bullet-resistant vest, acrylics, that is for battery covers, lightweight glass alternative, vehicle tail light covers, eye lenses, bone, cement, or medicine. Polypropylene are used in toys, sanitary tissues, heat-proof medical equipment, rope, string, laboratory equipment, detergent-proof food containers, automobile components, and folders. Polyvinyl chloride is used in cabinets, fume hoods, tanks, electrical insulation, toys, pipes, fittings, flooring, medical devices. Teflon, flange spacers, gaskets, non-stick cookware, machine parts, gears, wire lubricants, and for sliding doors. Those are the thermoplastics. We have now the elastomers. No? Elastomers are polymers that stretch and then return into original form. So as you can see, those are the bushings, no, the cascade, the shock absorber covers. So those are the polymers. Thermosetting plastics are plastic that can be softened on heating but become permanently hard on cooling. So as you can see, the thermoplastics can be melted repeatedly like those Lego blocks. Thermosets, one shape cannot be melted. So the thermosets are polyurethanes like paints, coatings, print rollers, footwear, sealants. No, as you can see, our footwears once you burn it, no, it decomposes. No, epoxy resins, melamine formaldehyde like adhesives, laminates, urea formaldehyde like plywood foam, electrical items, doorknobs, toilet items, adhesives, polyester resin, which are casting material, And bakelite, precision-made parts for vehicle disc brakes, cylinders, knobs, plastic wares, electric products, and insulation, plugs and socket, automotive parts, light bulb supports, and kitchen hardwares. So these are the different thermosets or the thermosetting plastics. The composites are material that are multi-phase material obtained by artificial combination of different materials to attain properties that includes components that cannot attain. Example is lightweight brake disc obtained by embedding silicon carbide particle in all alloy matrix. No? As you can see, that those are the carbon fibers. So those are composite materials. So density is an important consideration in relation to product weight and size. For portability, have high density. This means that the weight per unit volume is high, as you can see in the dumbbells or the weights. No, even though it's very small, but the relative weight is very high compared to the size of the object. Electrical resistivity. This is another characteristic of metal. We have the electrical resistivity is an important consideration in selecting particular materials as conductors or insulators for particular design contexts. So metal has a characteristic of electrical resistivity. Thermal conductivity is an important consideration for objects which will be heated, which must conduct heat or which must insulate against heat. So as you can see in the figures, no, the metals has thermal conductivity, but at a certain point it's heated, but it turns into a conduction of heat. Thermal expansion. It is the tendency of matter to change its shape, area, volume, and density in response to change in temperature, usually not including phase transition. As you can see in the figure, no, the metal is expanded into thin shapes, no, or thin foils, no, for specific uses. So hardness is an important consideration where resistance to penetration or scratching is required. No? So metal has also characteristic of hardness. As you can see, they use it for gears, drill bits, no? For hammer, for fans of motors. Ductile, a material which can undergo considerable deformation without rupture, is called ductile material. A material can be stretched, drawn, or hammered without breaking. But as all other materials, there is what you call a tolerance. No, when you reach the tolerance level, it will break. No, but there is some of the characteristic of metal that is very ductile. No, so the tolerance for breaking is very high. Okay, so this is the example of a material, a metal that was splitted due to stretching. Okay. Brittle, a material which cannot undergo any deformation, is called brittle material. Brittle material has a tendency to break into pieces easily. No, like cast iron, it's very brittle, but it's hard, but it's very brittle. No, so when it has a low tensile strength, but it is very hard. No, so another mechanical properties is stiffness, the ability of a product to withstand bending. No, so this is another property of metal. No, stiffness. So another mechanical property is the tensile strength, the ability of the material to withstand pulling forces. No, so these are used for springs, used for metal tensile metal sheets, and reinforcing bars. So those are metals that have high tensile strength. Another mechanical property of a metal, which is what you call the ductility, the ability of the material to be drawn or extruded into a wire or other extended shape. No? So this is the ductility of the metal. The toughness, the ability of the material to resist or the propagation of cracks. No? So another property of the metal is for using for constant load. No? And this type of metal has this characteristic of toughness. So another one is the sonorous. This means that they produce a ringing sound when hit. This property allows it to be used for making bells or instrument, no? Music instrument. So metals, there are hundreds of metals which are used in engineering. All the metals are extracted from quarries in the form of ores. They are made pure by some special methods in the industries. There are classification of metals. Metals are classified into two main groups depending upon the presence of the iron content. So we have the ferrous metal, as explained before. All those metals which contain iron as a chief constituent as called ferrous metals. These are pig iron, rough iron, and the cast iron. So the higher the carbon content, the harder the metal. Okay. So as you can see, these are the cast iron. Okay. Used for engine blocks, no, drainage covers. The low carbon, which is the used for grills, no, for nuts and for certain numbers of cans, no, for body parts, no, those are the low carbon steel. Body parts of the car or vehicle. The medium carbon steel are used for the because of this is a medium what you call this medium carbon content, no, can be used for making nails, used for the equipments or tools, and they can use for making cables. High carbon steel, no, now these are used for cutting tools, no, for saw and chisel, or for punching. This is a punching tool. So we also have the ferrous metal, which is a stainless steel. These are metals that are used for kitchen sink, no, stainless steel for cooking equipment and utensils. Non-ferrous metals are those metals which do not contain iron as a principal constituent, are called non-ferrous metals, such as zinc, lead, nickel, chromium, silver, platinum, gold, and all other metals except steel and iron. So non-ferrous metals are soft. Okay, they are soft. By alloying with other materials, they form a new material and become stronger. So from a soft material, they become now stronger because they are alloyed with other materials. Or, no? So these are known as the non-ferrous alloys. So non-ferrous alloys are like aluminum, which can be used for wirings. Because these are lightweight metals, no. So these are used for cans for soft drinks. We have a non-ferrous material which is called copper. No, this has high conductivity for electricity, same as aluminum. So this was also used for piping of water. Now it's only used for gas, no, or medical gas. So another type of non-ferrous material is tin, no, which are used for the PCBs and for the tin cans, or for the other materials. Lead is also used for this. This is another non-ferrous alloy, lead, and brass. Okay, so brass are used for these are laxet. Sometimes laxet are used for brass. Sometimes for nuts and bolts. Okay. Steel is an alloy, no, mixture of two or more than two metals, carbon and iron. It is most important metal which is widely used in reinforced concrete construction of civil engineering. So there are different types of steel. We have the low mild soft steel, which is the plain carbon steel, the medium carbon steel, and the high carbon steel or the hard steel. So the low mild steel or the soft plain carbon steel, The carbon content is 0.15 to 0.3. So it has a low carbon content. No? It is ductile, malleable. It corrodes quickly. It can easily be forged, welded, and riveted. So you can weld it. No? The low carbon steel, you can weld the low carbon steel. No? It can withstand shocks or sudden impacts. It is not much affected by saline water. So it doesn't corrode easily. No, it corrodes, but it is equally strong in tension, compression, and in shear. So uses of the mild steel or the round bars are extensively used as reinforcement in construction. It is extensively used in manufacturing of various tools and equipment, machine parts, railway tracks, transmission towers, and industrial buildings. These are samples of mild steel bars, mild steel plain bars, mild steel bars. Medium carbon steel, so this type of steel is, the carbon content is 0.3 to 0.8. Okay, medium steel is a characteristic between those low carbon and high carbon steel. So it is the medium, type of carbon steel. It is widely used for boilers. No, high carbon steel. This one is another type of steel, but high carbon content, 0.8 to 1.5. No, carbon is rendered to make it harder and tougher. No, its structure is granular. It is more tough than and elastic than mild steel. It is easier to harden to temper. It is more difficult to forge and weld. So the hard steel or high carbon steel, there is a difficulty on welding the high carbon steel. Okay, comparatively, it is stronger in compression than in tension. It withstands shocks and vibration better. So uses of high carbon steel, it is used for pre-stressed concrete, making tools such as drills, chisels, fine types of cutlery. It is also usually used for manufacturing knives, razors. It is used for manufacturing parts of the machineries. Okay. Now, reinforced concrete steel bars. So these reinforced concrete steel bars is strong in compression, but is very weak in tension and shear. As mild steel bars are strong in tension, therefore mild steel bars or high carbon steel bars are embedded as reinforcement in concrete to make good in the deficiency of the plain concrete. Therefore, round, flat, or square bars too can be used for that purpose. Welded wire mesh and expanded metal too are used as reinforcement in the cement concrete. Commonly deformed bars or twisted bars are used in cement, concrete. Therefore, reinforced concrete bars sections will carry compression as well as tension safely without failure. In this section, compression will be taken by the concrete and tension will be taken by the steel. So that the purpose, basically the main purpose of the steel in reinforced concrete structure is for the tension. Okay. Non-ferrous metal, we have aluminum, as I've explained earlier. It is commonly used as non-ferrous metal. No, it is color is silvery white. No, it's a ductile material. It is very light in weight. It's very good conductor of electricity. It is used for making doors, window frames. No, used for roofing, piping. Another one is copper. No, it is mostly used non-ferrous metal. Its color is reddish brown, very ductile, excellent conductor of electricity. It turns green when it's exposed to sunlight. It stands corrosion. It is soft, highly flexible. It's very soft, no? The copper wire. It is used for winding electric motors, generators, transmissions of electricity. Its sheets are used for damp proofing in buildings. Lead, no, it is widely used in building construction and has drawback in being poisonous. So they discontinued the use of majority of the lead. No, it is a bluish gray material. It can be cut with a knife. It is very ductile. It does not corrode. No, it was used as a base for making paint. No, tin is the most used protective metal used in a construction activity. So this is now the most commonly used material, the tin. No. It is lustrous silvery and white metal. It is very high ductile, good conductors of heat and electricity. It is used to give protective coatings to iron and steel sheets. Zinc is the commonly used in buildings, construction either as a base for paints or protective coverings for metals. It is bluish-white crystalline metal. It's brittle or ordinary temperature. It is ductile between 100 to 150 degrees centigrade. It is a good conductor of heat and electricity. It resists corrosion. The uses for zinc is the galvanizing of iron sheets and pipes. No? It is also used for batteries and printing blocks. It is used for preparing paints. No? So this is the alternative material in preparing paints in replacement of iron of lead. Non-ferrous alloys, we have the brass. No? It's very strong. Ductile alloy resists of corrosion. The bronze, no? It is resist corrosion. It takes fine polish. Corrosion is a method of corrosion control. We have the corrosion is a conversion of metal into various compounds by natural means of agencies as described as corrosion. Corrosion of ferrous metal appears in the form of rusting, as you can see in the pictures. So one is formation of oxides, as in cast iron, reaction with oxygen, carbon dioxide, and water, and results formation of bicarbonates, which in turn alters into bicarbonate and finally changes to hydrogen hydrate oxide, which is the rust. Okay, so protection against corrosion, we have what you call electroplating, galvanizing, tin plating, metal spraying, and painting. I will explain some of this electroplating. So this is a method involves the use of electric current to give coating of chromium or nickel, which is highly resistant to corrosion. So they bath the metal into cyanides. No, so this is very poisonous. This procedure is very poisonous. So another material such as carbonates and phosphates may be added to increase conductivity. Another is glazing. So this is the commonly used for our metal sheets for roofing, the glazing. No? This is the glazing process. They clean first the metal, they rinse it, then they clean it again by pickling bath, then fluxing, and then they dry it out, then they dip into molten zinc bath, and then they inspect it for quality control. So another is tin plating. So this is similar to the galvanizing process. The iron products are thoroughly cleaned and washed, then dip into hot molten tin, which give protection against corrosion. So this is what you call the stainless steel method, right? Okay. Okay, so that ends our lecture. So I will just look at the blackboard. No? Sandali lang for a while. Sumabay pa yung aso ko sa pagsasalita ko. Ang ingay. May question ba kayo doon sa ano natin? May question kayo? Ano ba yung question?